This is number 48 on page 187. So this is number 48, page 187. And it asks us about, or tells us that there's a suitcase starting from rest. It's 10 kilograms. It slides 3 meters down this incline that's 30 degrees, and then it slides 5 meters along here. So we know it goes 5 meters along here. The ramp is frictionless, the floor is not. So we want to know the speed here. So A, we want to know the velocity right here. Velocity equals. All right, now let's go back and think. In chapter 2, we learned about all the kinematic equations like VF squared equals VI squared plus 2A delta X. I could use that to find the velocity here, but there's a much easier way in this chapter. So in this chapter, the only equation we have with velocity in it is kinetic energy. And we know kinetic energy is equal to 1/2 mv squared. All right? So if I can find the kinetic energy at the bottom of this ramp, and I know the mass already, so if I know kinetic energy and I know mass, I can find the velocity. And I do know mass is 10 kilograms. So we just need to find the kinetic energy right here at the bottom of the ramp. And so to do that, we have to go back and think about our chapter and think about the fact that this has, up here, this has potential gravitational energy, and that's it. That's the initial energy. It has no kinetic because it starts from rest. So can I find the potential gravitational energy up here at the top? And the answer is yes, as long as I know the height. Well, there's where your geometry and trig skills come in. If this is 30 degrees and this is the hypotenuse is 3 meters, then this side is, you're going to, your calculator, you're going to say 3 meters times sine of 30. That's going to give me 1.5. So this is 1.5 meters high. So yeah, knowing that, I can find the gravitational potential energy, which is mgh. You might be thinking, well, that's not kinetic, and you're right. So just hold on. Let's put our numbers in. 10 kilograms, that's our mass, times 10 meters per second squared, times the height I just found is 1.5 meters. And when I do that, I'm going to get 150 joules. So what does that mean? Well, if I know the energy here, that's the initial energy, that energy is the same here, it's the same here, it's the same here, it's the same at the bottom. It's 150. That's what's so easy about this. The energy remains constant, it just changes form. So what happens is it goes from this point, like right here in the middle, well, half of it changes to kinetic and the other half is still potential. When it gets down here, there is no potential left, so it's all kinetic. So therefore, the 150 joules equals the kinetic energy at the bottom, because that potential energy changes into kinetic, and that's equal to 1/2 times 10 kilograms times v squared. Now if I solve this, it's going to be 150 divided by 5, right? Half of 10 is 5, and I'm going to take the square root of that. That's 30. Take the square root of that, and I'll get 5.48. So you take the square root, and you should get 5.48 meters per second. And if I look in the book, they get 5.42, but that's because we use 10 instead of 0.8 for our acceleration due to gravity. All right, that's the first part. The next part is find the coefficient of friction. Well, when it hits the floor right here, it now has one force acting on it, and that force does work. It does work over, so this is 10 kilograms. And we have a force of friction working backwards. So this is one of those work equals the change in kinetic energy. And guess what the change, and we could answer C first. What's the change in mechanical energy? Well, I start out with how much here? 150. What do I end up with right here? I end up with 0. So what was the change in kinetic energy or the change in mechanical energy? The change is 150. So I know work equals 150 joules, because that's the change in kinetic energy. I go from 150 here to 0 here after 5 meters. So now I've just got to figure out what to do with this work. And all I got to do is remember that work is force times distance. Well, what kind of force do I have? Friction times distance equals 150 joules. Can I find friction now? Well, yeah, because I know this right here is 5 meters, right? So if I just put in my number, this right here is 5 meters, and I'm going to say 150 divided by 5, and that's going to give me 30, so I know my frictional force has to be 30 newtons. Well, how do I find mu? Well, the Fun equation. Remember the Fun equation? F equals Fun. And so it's going to be mu equals F over N, which is going to be 30 newtons. What's N? That's the weight. Remember remember that we do have to do a little bit of force here. We have normal force up and mg down, and mg is going to be equal to 100 newtons. Therefore, the normal force is 100, and we get 0.3480 for our coefficient of friction. So that's our answer for coefficient of friction. And then the only thing left, I've already answered, is what's the change in mechanical energy. Well, if you start out with 100 here, so this is B, this is A, and then C is simply 150. It equals 150 joules, the change in mechanical energy. The change in mechanical energy, because it starts with 150 and ends with 0. So I guess it'd be negative 150, because this work does negative work. In other words, it takes energy out of the system. So that is number 48.